Hi folks, in today's video we are going to be looking at substitution reactions and the three different types that you need to learn for advanced higher chemistry. So there are three different types that you need to learn in advanced higher chemistry. You've got free radical substitution, electrophilic and nucleophilic. But what is a substitution reaction? Simply, a substitution reaction is a reaction where a hydrogen or a functional group is replaced by a different atom or functional group, so you're just simply swapping something out. So if we have a look at this quick recap from higher, we've got three different steps for a free radical substitution. You've got initiation, and that involves breaking UV light breaking a bond to form two radicals. Propagation, and that is when a free radical merges with or breaks another bond to form a new free radical in an atom. And then last but not least, termination involves two free radicals joining to form a stable molecule. Now another way of looking at this is having a look at the dots. So we've got no dot to dot for initiation, dot to dot for propagation, and dots to no dot for termination. So what kind of examples would go under free radical substitution? So alkanes are probably quite a good one for this one. So they react rapidly with chlorine and bromine. As long as the UV light is supplied to the reaction, then it's going to work. So you can make different haloalkanes, but it's not a sustainable way to make haloalkanes, because if enough chlorine is added to methane, for example, you can have four different products. So we can have chloromethane, dichloromethane, tetrachloromethane, trichloromethane, as I've got here. So it's not really the best way of making a specific haloalkane. There are other reactions that are better to do this. And if you have a look, each of these reactions, a hydrogen atom has been replaced or substituted by a chlorine. That's how it's a substitution reaction. So here we have something new, something called an electrophilic substitution. So an electrophile is a positively charged ion, and this usually happens to benzene and benzene derivatives, in other words, benzene with other things added on. They undergo this type of reaction. However, benzene is relatively stable. It doesn't really like addition reactions. However, if you have the right catalyst and conditions, it is possible. For example, we have benzene going to bromobenzene, and we have iron bromide as your catalyst, and that will help substitute your hydrogen here for your bromine molecule. Here we have a couple of different examples. So we're going to start with methylbenzene at the top. So what happens is we add aluminium chloride as your catalyst to substitute your hydrogen for your methyl group. Now at the bottom, this is called the Friedel-Crafts reaction. It's just a fancy term that we call for it. So ethane, propane can all be substituted on using this same method. And let's have a look at the other side. We can go to concentrated sulfuric acid, and we can add this benzene sulfonic acid, so this kind of acid group here. Further down we can add NO2+, which is called the nitronium ion, to add on NO2 at the top. And then last but not least, as we've mentioned previously, we can add chlorine to make chlorobenzene. And the final substitution reaction that you need to learn for advanced higher is called a nucleophilic substitution. So a nucleophile is a particle which is attracted to an area of positive charge. So negative ions, molecules with lone pairs can all be considered as a nucleophile. So for example, we've got chlorine. Also with lone pairs, we've got water and we've got ammonia, so they can all be considered as a nucleophile and undergo nucleophilic substitution. Here we have some examples. So we've got a haloalkane, so your RX, X being your halogen. So if you add O- or OH-, so your hydroxyl group, you can make an alkanol, or sometimes called an alcohol. If you add NH3, you can make an amine. You can also make an ether, which is something that you'll learn further on in this topic, by adding oxygen bonded to another alkyl chain. And then if you add CN, you can make a nitrile. So R just represents any alkyl chain, and then from further, previous, an alkyl chain is just something like this with lots of carbons and hydrogen, so just a hydrocarbon chain. And that's three examples of substitution reactions. Feel free to have a go at some questions just to understand this concept, and if you've got any questions, feel free to let me know.